Hey everyone, here we are for step number 2 for your Catapult Quadratic Formula Assignment. So what we're going to do now that you've already identified your variables is we're going to attempt to solve for A, which is your amplitude. So how can you use your data to accurately calculate your amplitude? In the last video, we were able to identify our variables. We have our x coordinate and our y coordinate for our vertex. So again, that's going to be how far away we were from the catapult when we reached our maximum height, and then what was our maximum height. That's what those letters represent. Then our roots are going to be when height was 0. So root 1 is at 0 meters because that's where I launched from. It hadn't launched yet, so that's one of my roots. And then my other root is going to be my maximum distance, which is 1.6 meters. So these are the numbers I'm going to be using to figure out what my amplitude is. For your work, I mean, you have to use your own numbers, just to be clear. Don't use these numbers to find out your quadratic formula. You have to use your own numbers. So just substitute your numbers in while you're doing this. So in order to do this, we need to calculate the amplitude of our projectile before we can create the quadratic formula. You're going to use your vertex data and a maximum distance into the factored equation. So if you forgot what the factored equation is, this is what it is. We have y equals a times the binomial x minus root 1 times x minus root 2. So this is the factored form of the equation. So now that we have some data to play with here, I can actually plug in the stuff that I know here. And you can see I've color-coded these so that I know what goes where. So if I plug in the things I know, that equation is going to turn into 0.2 because y is equal to 0.2. The a, I don't know what a is. I'm trying to find that out, so that's going to stay what it is. I can plug in my x, which is 0.8 for x. Root 1 was 0, so that's how I got that 0. X is still 0.8, so that's why that number matches this one here. And then root 2 was 1.6. Notice that these minus signs, those are important. Those have to stay there. All of my data is positive, but in this equation, it's subtracting the roots, so I need to make sure those subtraction symbols are there in that filled-in equation. So what we're doing for the first step is we take our variables and we plug them in. I've color-coded them here for you. If you want to do this to your problem right now as we go, pause this and go for it. The next thing you're going to do once you have that filled-in equation is you're going to actually do some stuff to it. Once you've plugged in your known variables, you simplify and rearrange the equation to solve for a. So we have our regular factored equation. We plug in what we know, so this is the same equation that I had on the previous slide. Now, in order to simplify and rearrange this equation, there's a series of steps I can take. Some of you might know how to do this, in which case you just go for it. But if you need a quick reminder for how I can rearrange this equation, I'm going to walk you through some steps. So once we have this 0.2 equals a times the quantity 0.8 minus 0 times the quantity 0.8 minus 1.6, the first thing I'm going to do is just simplify. I'm going to make this a lot easier for me. So I'm going to, in these parentheses, because I do my parentheses first, I'm just going to simplify them. So I have 0.2 is equal to a, and then I simplified this 0.8 minus 0 is just 0.8. And then I have 0.8 minus 1.6, which actually makes negative 0.8. So I'm keeping that symbol, and I'm just simplifying that math. I'm just cleaning up my equation as I go. Now, once I'm there, I still have some more simplification that I can do before I can solve for a. The next thing that's going to happen is I'm going to take these 0.8 and negative 0.8s, and I'm going to multiply them together. Again, I'm just trying to clean up my parentheses so that it doesn't look so messy. So now I have a is equal to, a is multiplied by that negative 0.64. Now, in order to solve for a, for my amplitude, I have to get that a by itself. And the best way to do this is to do the opposite of what's happening here. Right now, this is multiplication. And the opposite of multiplication is division. So in order to get a by itself, instead of multiplying by negative 0.64, I divide by negative 0.64. And whatever I do to that side, I have to do to both sides. So that's why on this side of the equation, I now have 0.2 divided by negative 0.64. And don't forget, that symbol has to go with it, which is why this is negative. Now, once I'm here, all I have to do is simplify this, and I have my answer for a. So if I do a little bit of math, plug it in a calculator, If I do 0.2 divided by negative 0.64, I get an answer of negative 0.3125. And that is my amplitude. If you get a really long decimal, I strongly recommend rounding to maybe 4 decimal places. Don't round to like a tenths place, don't round to a hundredths place. Your answer just won't be specific enough. So you want to make sure you're careful and have at least 4 decimal points when you're calculating your amplitude. At this point, your amplitude should be negative and it should be pretty small. That's it for this second step. You have now solved for your amplitude. If you're ready for step 3, go ahead and move on to the next video. Thank you very much.